Recording in progress.
Hello everyone. So how are you? You can hear me, right?
Yes, sir.
Okay. So I guess in the previous class, I guess we did HOF, right? Higher order functions. And we discussed few things around exceptions, exception handling, a kind of idea. Matlab, this part you can ignore for now. If you haven't understood completely, you can ignore the error exception handling part. So other than that, we discussed about functions, right? And we discussed about few of the array methods, at least these first 7 methods. We need to discuss few more. Okay. So let's begin. Let's start discussing the rest of the array methods. Okay. So I'll simply say more array methods, right? So these are simple methods, although you just need to understand them, and they are very helpful while working with the JavaScript arrays, especially. So I'll say HTML5, right? And we'll have app.js, and here I'll simply have array methods and open with live server. All right. So let's see the first method. All right. So there is this method called map. So map is basically used to transform the array. So for example, let's say you have an array, right? Let me just do it here only, right? So for example, you have an array of numbers. I'll call it nums, and for example, it has numbers like this, 7, 8. Now, what I want is I want to transform this array such that I get the output as this. Let's say the resultant array should be this. It should be, let's say, 1, 4, 9, 16, 25, 36, 49, and 64, right? Something like this. So here what I'm doing is I'm doing the square of each number, right? So whatever the numbers are there, I'm simply transforming the array such that we get the square of each number, right? So if you want to transform the array to some other form, right, from one form to another, right, then map is the method that should come to your mind, right? Now how does it transform? Let's see that. So if you see the signature of map method, right, the definition of map method, it basically accepts a callback function, right? Now the question comes is what is callback function, right? So that's the another thing. So let's discuss this. It's a very simple thing. So as I told you, let's say there is this function called, for example, function, or we saw this example of, I think we saw one example yesterday, right? That was much better example that we can have. Class 8 in the HOF part, right? HOF. Let me open that part. So open. So this part. I'll just open it in Visual Studio Code itself, right? So yes, so we have this function. We had this example yesterday, right? Wherein we created one calculate function, and in calculate function we are passing in another function such as diameter, area, perimeter, or square of radius, right? So we are passing these functions to the calculate function as an argument, and this function was receiving this another function, the logic function, as a parameter, right? So in this case, right, in this example, we can call this diameter or area or perimeter function as callback function. These are our callback functions which are passed to the calculate method, right? And calculate method is known as higher order function. So this is the higher order function, and the function which is being passed is known as callback function, right? So the simple definition of callback function is the function. So these are the function which are passed as an argument to another function, and then they are called internally. So here we are calling internally, they are called internally by the outer function, right? So for example, in calculate, we are passing the diameter. Now this calculate function will internally call the diameter, which is happening right over here as well, right? So inside the calculate, we are calling this logic method, right? And logic method is performing the action as per its definition, right? So in this case, this logic is a callback method, right? We call it a callback functions, right? So let's see the definition MDN as well, right? What MDN says about callback function. Uh, okay, so I'll simply say callbacks MDN. So you can see right over here, a callback function is a function passed into another function as an argument, which is then invoked inside the outer function to complete some kind of routine or action, right? The way we were we were calculating the diameter, the area, and the parameter inside the calculate function, right? So it's the same thing. It's a very simple definition, right? So those are known as callback function. So please remember that the definition of callback function. And so here we are going to use the callback functions a lot, right? So for example, let me create a function called square, because corresponding to each number, we have to square the numbers, right? So I will simply say square, okay? So this square will take a number and it will basically return the square of the number. The number times 2, right? Number is to the power 2. So this is an arrow function basically which I have written. So if we just have a single argument to the function, single parameter to the function, to the arrow function, then you can remove these parentheses, right? These parentheses are also not required, right? They are optional. You can remove them if you just have one single parameter, not the two or more parameters, right? So if you just go and call the square method, and if I do 2, so you can see we are getting 4. If I do 10, then we are getting 100, which is absolutely fine. Now let's talk about the map. So map method can be called onto an array, right? These are array methods. They need to be invoked on an array. So I'll simply say nums dot map, right? And now this map method accepts few arguments, and one of the argument is the square method, the the callback function basically, right? Which map will internally call to create a square and will map it to some another array. We will see it in a short while. So nums dot map, and I have simply passed down this square, right? So now what will I get is out of this, so I'll get a new array, right? So square of nums, so I'll get a new array. So map method basically returns an array, right? It returns another transformed array, and we can store it in some variable, and then we can print it. So I'll print the nums array as well as console dot log square of nums, right? So what is happening right over here is that the map method is iterating over each element. It is picking up one element from the array. So it will pick one, and then it will give this number to the square method, because the square method also accepts one single number. It will simply do the square of that number and will return it. So whatever the value is being returned by the callback function, that is mapped to the this new array, and then we are printing it, right? You can see we are getting the square of numbers, right, as intended, as expected. So this is the expected output, right? So what do we want it to do? So this is a very simple example wherein uh, we are using map method. Similarly, let's say if you want to do cube of numbers, for example, right? So here what I'm doing is I have defined a function outside and then I am passing it. You can also write an inline function. You can also write an inline function inside the map only, right? So what do I mean by that? So I'll just write it here. So I'll simply say const cube of nums is basically nums dot map, and I'll simply write an inline function. So I can write an anonymous function, right, or a named function as well. So I'll write an anonymous function. So this function will accept one number, because see, this function, if you have to square or if you have to perform the cube of a number, then this function should accept that number as an argument. So this function will accept a number, and then it will simply return cube of that number. So number raised to the power 3, right? So done, that's it. So it's an anonymous function. If you want to have a arrow function, you can have that as well, right? So So you can see we are getting cube of the number. Now let's say you have to create the square root of each number, for example, right? So how will you do that? So you can simply say square root of nums, and I can simply say nums dot map, and I'll use an arrow function now. So we have an arrow function, and arrow function will also accept one number right over here. So it will accept a number, and what it will return, it will simply say math dot sqrt of number, right? Math dot sqrt. So that's the method of number. So I'm using the math object to compute the square root. So map will pass each number one by one to this callback method, and callback method will keep on computing the square root, and map will uh, basically map that output to the resultant array, right? So I can simply say console log square root of numbers. So I can simply say square root of nums. Save. You can see we are getting the square root of numbers, right? I hope this is clear to everyone how map is working. Any doubt in this? Anything you are not able to understand? Tell me. Clear?
Yes, sir.
Okay. Now let's see the definition. There are few more arguments which we can pass to this method, right? So I'll just say array methods and dn, and if you go to map, okay, right. So so you can see a callback function can accept these three things. It can accept an element meaning this element of an array. Then the next thing it can accept is the index, right? So since this is at zero index, this is at one index, this is at second index, third index. If you want to use index inside the callback function, let's say you want to utilize it for some purpose, right? Then definitely you can do that, right? So you can use the index, as well as the third argument is the array itself. You can access the whole array inside this callback function, right? Inside this callback function, you can do that, right? So these are the three things which callback function can accept, right? So that's fine, right? So if you need an index, I'll just give you an example, right? And the nums as well, right? So these three things can be accepted. So I can simply say you can print them, right? Console log index, and I'll console log nums each time, right? So it will be printed 10 times, I guess. I'll just remove these consoles, and if you now see the output, you can see we are getting 0 and the whole array is getting printed, because this is the first time, right? We are, the map method is at 0th index, right? It is computing for 0, then it is computing for first, then second, then third, fourth, five, six, and seven, right? So we are able to access all of these three things inside the map method, right? So you can utilize it if you want to access the array or index for some reason. You can access that inside the callback function. It depends upon the use case, right? So this is it. This is about the map method. The other methods are very similar to map. Then there is this method called filter. So what does filter method do, right? So for example, let's say there are more numbers in it: 9, 10, 11, 12, 13, 14, 15, for example, right? So these are all numbers which we have. Now I only want to filter out the even numbers out of it, right? So what I can do is I can simply create a method called isEven, right? And this method will accept a number, and it will simply do the check that if number modulus 2, if that is equals to 0, then return true, otherwise return false. So this is even method basically checks for the uh, whether the number is even or not, right? So I'll simply say is even, and I'll check for, let's say, 7. So it will say false. If I check for 8, so it says true. Yes, 8 is even. So here, this callback function, it returns a simple Boolean value, right? So what filter does is, so for whatever value, the if callback function returns a true value, right? So filter is basically based on true and false, right? Which is being written again by the callback function, right? So if inside the filter, right, if callback function returns a true value, then that value get mapped to the resultant array. If it returns the false, then that value will not be mapped, right? So for example, let's say if I now call, if I again call the filter method on this, right, and I'll say is even, right, like this. So what filter will do? Filter will get the numbers one by one from this array and will pass those numbers to the is even method. Is even method accepts that number, checks for whether the number is even or not by simply doing the modular operation. So if it returns true, then it will be mapped to the resultant array. So for example, let's say even numbers, right, like this, and I can then print it like this. And let me just remove these console logs, right? So you can see, so I have to print even numbers, right? So you can see we are getting the even numbers printed right over here, right? Similarly, we can write for odd, and that you can do inline as well. So for example, odd nums, so you can do nums dot filter, uh, filter, and I can simply say, for example, I can write an inline method, right, or an arrow function, right? We generally write arrow function because they are more compact, right? And you don't have to write multiple lines for that, so it takes very less space. So it will accept a number, and I will simply say number modulus 2 not equal to 0. So if it is not equals to 0, that means it's an odd number, and this expression will return true. And if it returns true, the number will be mapped to the resultant array, right? So I can simply say console log odd nums, right? This is a very basic logic, right? So you can see we are getting all the odd numbers filtered out from this nums array, right? So this is a filter method. It is based on true and false returned by the callback function. So that is fine. Similarly, we have a reduce, right? When we want to basically compute a single value, right, out of this, when we want to produce a single value out of this array, then we can use reduce, right? So let's see the reduce method as well. So for example, let's say I want to compute the sum of all these numbers, for example, right? I want a sum of all these numbers. So I can simply say uh, nums dot reduce, and inside this, a callback function accepts two things, right? So there are two things that you need to pass basically. So the first is the current number, and second is the, let's say if we are computing sum, right? So this is the accumulator value. Here we accumulate all the result, right? So we can call it a sum because we are accumulating sum of each number, right? And uh, what I'll return is, I'll simply say return, and I'll simply return number or sum plus number. And so reduce method accepts two argument. First argument is the function, and the second argument is the initial value that you want to set to this accumulator, right? So this accumulator by default, if you do not pass anything, right? So for example, in case of an array uh, which is this array, let me, right, which is this array, for example, 1 2 3 4 5 6 7 8 9 10, for example, this array. So in this case, if you do not pass the initial value of accumulator, then accumulator, that is this variable sum, when we initialize to the first value, and reduce will start computing the sum from the second value, right? So it will first pick the second value, then third, then fourth, and it will keep on adding that value to the sum variable, right? So how it will work, let me tell you. So it will take one, right? And sum is initialized to one because we do not have the initial value. So we'll get one. So it will simply return sum plus num. So sum is 1, 1 plus 2, right? 1 plus 2 is 3. That will get accumulated to this sum variable. So this sum will be updated to 3. Then we will say, we will go to 3, and we will again do sum plus num. So that is 3 plus 3. So this will be updated to again 6, right? And then it will go to 4. So it will be updated to 10. Then again it will go to 5, it will be updated to 15, then again it will go to 6, it will be updated to 21, and it will keep on iterating throughout the array, right? So this is how it is working. But if you want to pass an initial value, for example, then you can pass it here. So if I pass 0, then sum is initialized with 0. And in this case, when we initialize the value, right, whenever we initialize the accumulator, whenever we initialize this accumulator parameter, then in that case the reduce method starts from the 0th index. It starts passing the number from the 0th index and not the first index, right? So that's the kind of difference which it brings if you pass the initial value, right? And we can simply uh, store the sum, right? Sum of nums, for example, like this, right? And I can simply print it, console log sum of nums, right? So we are getting 120. Hopefully this is correct. So 15 into n minus 1 divided by 2, 15 into 7, right? So sorry, so 15 into 8, right? That's correct. Yeah. So we are getting the correct answer, that is 120, right? So we are able to compute the sum right over here. Similarly, let's say now for example, you only want to compute the sum of odd numbers, for example, right? So how you will do that? Please do that. You want to compute the sum of odd numbers, and before jumping onto that, let me show you this initial value as well. So if I put initial value as 20, so this sum will be updated to 140 because the sum from 1 to 15 is already 120 and you are having the initial value as 20. So 20 plus 120 is 140, right? So this will be updated to 140, right? So whatever initial value you will give, that in that value, the reduce will start accumulating the whole array, right? All the numbers basically, right? So we can put it 0 for now because that is relevant to us. And now you have to do is, so you have to basically compute the sum of all odd numbers using reduce reduce and you can also try sum of all even numbers using reduce, meaning just for the sake of understanding the syntax and all of those things, right? I know you know how to compute, how to check for even and odd numbers, both are the almost same thing, right? But you can write it for the confidence, right? So please try, everyone has to do this, right? And yep, you can, all of you should do it, right? Please do this now, and then we will move forward, right? We'll check with other methods, what all other methods are. ये करना है सभी को. I'll give you some time, maybe 5 minutes. Done. Okay, Kritika, accumulator and current. Even dot reduce. Why even dot reduce? It should be nums dot reduce. No. मतलब देखो ओके तो आपने ऑलरेडी आई गेस इवन नंबर ले लिया उनका सम किया है राइट विच इज fine but I wanted to compute the even and odd sum out of this array only right arr dot filter किया है भाई उसके बाद okay I guess you could have placed a simple if condition, right? That should have solved the problem. And one more thing I see right over here is the this if and else case, right? So you don't need to have if and else always, right? Just if and rest you can write the else statement outward, right? Since you are using the return keyword, then that will short circuit the whole code, right? So let's see. Even sum, even sum. For example, so I'll simply say nums dot reduce, and let's say I'll use anonymous function, and we are getting the number. And what I'll do is if number modulus uh, modulus 2 equals to 0, then in that case, right, so we have a number and the sum, right, the accumulator basically. So you can have any name right over here, right? So this is my accumulator right over here. I can simply say this should be nothing but number plus sum, right? In other case, what I can do is I don't have to basically uh, do anything, right? So I can add 0 as well, right? So this should work, right? I can simply return 0 in that case. Okay, because we need to return the accumulator, let's return the accumulator. Plain accumulator and nothing else, right? And I'll put the accumulator initial value to be 0. So this should work. Console log even sum, right? And save. Let's go right over here, and we are getting 29, right? So all of you getting 29 or something else, some other value for even up to 15. अरे बोलो भाई किसी ने नहीं किया
सर ऐसे खुद का एग्जांपल लेके किया था 1 to 6
okay so this should be
मेरा एक आंसर 56 आया था और दूसरा 64 आया था, तो शायद इवन वाले की वैल्यू 56 थी।
56
हाँ जी।
56 ही होनी चाहिए because 6 4 is 10 and 20 20 30 30 42 it should be 56
should return the sum instead of the number.
sorry
Should return number instead of sum. Number over here is the accumulator.
रिटर्न नंबर होना चाहिए
Number
One
is the
second, yeah.
Instead of
accumulator
sum.
over here.
line number 43
सर
One second,
actually
yeah.
the callback function in the reduce first argument is the accumulator and second one is the current
Understood. Okay, check था ठीक है तो मैं बीच बीच में चेक करता रहता हूँ तुम लोग ध्यान दे रहे हो या नहीं all right so this sequence is important here and you can see it in VS Code as well, right? So if you just write comma, so you'll see callback function, right? So okay, current index number and 1 second. Are you sure? Let's check for reduce. So correct. So first is accumulator, and then the second argument is the current value. That's correct. Accumulator and the current value. That's correct, yeah. Okay. So the first is sum and then the number, and this should work fine now. So all right, let's see. So here now we are getting 56, which is absolutely fine because we are not doing a sum operation in this case because the number is not even, right? We are simply returning whatever the earlier value it had, right? The accumulator, right? So it will basically kind of skip those values because the sum will not be accumulated for those numbers which are odd, right? So this is a very simple example. All right, let's do one more example and then we'll do few others. Okay. So now I'll give you something else. So for example, I'll give you the cart basically, the user's cart basically, and in this we have an object, right? So here we have the name of the product. For example, name of the product is iPhone, and then we have a price associated with it. So these are the attributes of the products, right? Then we have the next product. Name is, let's say, MacBook, uh, and then we have the price as 200, and then let's say we have another product. Name is, let's say t-shirt, uh, and it has got the price is, for example, let's say 50. uh, so this is a kind of array of objects, right? This is array of objects. What you have to do is you have to compute the total amount that user has to pay, right? So we have to find the total amount for this card, right? So whatever the items which are there, against those items you have to find the total of this. So can you do it? How we can do this? How can I do this? So see, we have to find the total. That means we have to somehow reduce the array to single value, right? So we can use reduce. So I can simply say reduce, and inside the reduce, we can have a function. And here I can call this, let's say, total price, comma, item, right? So what would be this item right over here? What would be this item right over here? This is the
Object.
accumulator.
Object.
This item would be a
Object.
object, because the element in this array is not just a single value. It's not a number, right? It is the complete object. So the item would be an object right over here. And what I'll return is, I'll simply return the total price, right? Total price plus, what should I write right over here?
Item dot price.
Item
Item
dot
dot
Item
price.
price.
item dot price, right? And initial value of total price should be 0. So I can simply say total amount, right? Something like this, total amount. So total amount will be computed and it will be printed. So let me print it and save. So you can see we are getting 350, which is absolutely correct, right? So this is how it works, right? So we use these methods a lot while working with the applications, right? So rest of the two methods you can explore on your own. These are also very similar and helpful methods, find and sum. You can try them on your own. The other methods are index of and includes, right? Both are almost similar methods. The only difference is index of basically returns the index, includes basically returns the boolean value, right? So that these methods we have already seen in case of array. So for example, I'll just use them on this thing only, right? On my nums array, for example. So I'll simply say console dot log nums dot index of. So for example, I want to find the index of 5, right? Whether the 5 exists or not, right? So index of 5 is 4 in this case, right? So we'll get 4. So you can see we are getting 4. And similarly, if we do includes 5, so it will give true. And if we give 100, then definitely the 100 does not exist inside this array, then it will give false, right? So we'll get false. In case of includes, if you do 100, right? If you do 100, then we will get -1, right? That's the includes index of functions way of telling that, okay, this thing does not exist. Okay, we'll get -1 right over here. So these are a few important methods which are very handy while dealing with the arrays in JavaScript, right? So please remember them. Now let's talk about something called scopes, right? Scopes are very important to understand, right? Let's see these scopes, and I'll simply say index.html and app.js, HTML, script, app.js, and I'll say h1 scopes, and let me open this. So all right, so what do you mean by scopes, by the way? What do you mean by scopes?
Boundary. What is
Boundary.
the boundary
Okay.
of the
Sorry, boundary of
function of the variable?
एक वेरिएबल कहाँ से कहाँ तक विजिबल रहता है वो उसका स्कोप रहेगा.
right. So scope is basically a region wherein you can access a particular function or a variable, right? So where they are accessible basically. So all the functions and variable, they are not accessible in all the places, right? They are accessible in a particular region. That region is known as a scope for that variable and function, right? So generally there are different type of scopes which exist in JavaScript, right? So there is this scope called global scope, right? Global scope. So I just say global scope, right? Then there is this scope called uh, let's say functional scope, right? That is the next scope which exists, functional scope, right? So let's try to understand these two scopes. There is third scope called block scope, right? Block scope, and then we have the next scope called you can say script scope, right? Script scope. So let's try to understand uh, first two scopes. So there is one more way by which we can declare variables. So far we have discussed that we can create the variables or buckets with the help of let and const, right? There is one more way of declaring JavaScript variable, that is var keyword, right? So var is nothing but the just a older way of declaring JavaScript variables, right? So before 2015, let and const were not there in JavaScript. So there exists was this var keyword, right? Wherein we were wherever we wanted to declare a variable, we were using this var keyword, right? So for example, if you want to declare a variable with var, so you can declare it console log a, console log a, right? So you can see if we are getting 100. So this is also a variable declaration, right? With the help of var keyword, but this is not recommended these days. This is just an older way of declaring variables, right? That is fine. Now, whenever, so what is global scope? Whenever anything is not inside of any other function, right? In case of var, right? In case of var, if any variable, right? If any variable or function they are not inside, they are not inside of any other variable, sorry, any other function, then they are said to be in global scope. So if anything is not inside any other function, right? If anything is not inside in any other function, then that particular thing is in global scope. So for example, this variable a, this is not inside of any other function. That means it will be in global scope. Now, if I create a variable with function keyword, right? And if I write add, and if I do x comma y, console log, let's say, or if I simply do the return of x plus y, right? So this is also a function, right? This is a function declaration. Now this function declaration is not inside of any other function, right? It is not nested inside any other function, so it is also in global scope. So both of these things are in global scope, right? So I'll simply write global scope, right? They are in global scope. Now for example, now there is one variable called, let's say, result. For example, I'll simply say result x plus y, right? And I'll return the result, right? So in this case, this result variable, because it was created inside the function, it will live inside the function only. It will not be accessible outside the function, right? You cannot write console log of result. You cannot do that. If you do that, then you might get undefined or an error, a reference error that result is not defined, right? We are getting a reference error right over here that this variable does not exist, right? Because it was created inside this add function, so it will live inside this function only. It will not exist outside this function, and this kind of a scope is actually known as functional scope. So here, result variable has functional scope, as simple as that, right? Because this is a function and this variable will live inside the function only. It will not exist outside the function. So that is fine. So this is the global scope, and whatever is created inside the function, whatever is being declared inside the function with the help of where keyword, uh, or let keyword or const keyword, it will live inside the function only. It will not be accessible outside the function. So that thing is known as functional scope, right? A scope of a function. So that is fine. Now comes the third scope, which is block scope, right? So what does we mean by block scope? So what is the block in JavaScript that we need to understand first, right? So this thing is a block. This is a valid block in JavaScript, right? So this block can be associated with if block. It could be a for loop. It could be a functional block as well. It could be a try and catch block as well, right? So any type of curly braces which you write, they constitute a valid block in JavaScript. And inside this, if you create a variable with the help of let and const, then let and const, since they have a block scope, they will only exist inside this block. They will not be accessible outside the block, right? So for example, let me create the variable. I'll simply say let a is 100, for example, and then I'll simply say let a is equals to let a is equals to 200, and I'll say console log a, and I'll do console log a. What would be the output of this code, this particular code? What would be the output?
100,
Sorry,
100.
in both the cases there are two
Yeah,
console
100.
logs.
First 200, second 100.
First one,
200.
200, then 100.
first one 200 and then 100, correct? So
Yes.
as I told you, this is a block scope. So what will happen in this case is if you just go and try to put a debugger, you will be able to understand everything, right? So what I'll do is I'll just put uh, a debugger here and a debugger here, and let's have a debugger here. So one more thing, right? So as I told you, if anything is declared, any variable is declared with var keyword, right? And if it is not inside of any other function, then we call it is in global scope, right? We say it is in global scope. And same goes with the function. If you declared a function like this, right? So it is also set to be in global scope because it is not inside of any other function. That is fine. It is in global scope. Now, if you declare a variable with let, right, and it is not inside of any block, right, whether it is a block of a if whether it is a block associated with if or a for loop or a try and catch block, or let's say a functional block, right? So if it is not inside of any block, then it is in script scope, right? So this is the outermost scope for the let and const, and outermost scope for where is global scope, right? So this global scope is nothing. In case of browser, this global scope is basically a window object. So there is something called a window object inside our browser. We will discuss it later on. So this window object is the global scope. So if you are creating a variable with like this, that means this variable is getting created, this a is getting created inside a window object, which is nothing but our global scope. We call this window object a global scope, right? So that is fine. And okay, so global scope is there, functional scope can exist. Then we have a block scope, right? This is a block, valid block in JavaScript. And if let and const, they are not inside of any block, then they are set to be in script scope. So let's go and give it a shot. Let's try to figure out whether this thing exists or not. So if I just refresh, right? So you can see the scopes here basically. So you can see the scope. So you can see there is a script scope, there are global scope, there are other things, right? So let's focus on this part. So there is a script scope, and you can see A is created inside a script scope. Since this line has not been executed completely, so it has not been assigned the value of 100. So as soon as I execute this line, right? As soon as I execute this line, you can see uh, you can see inside the script scope, A has got 100. That means this line uh, has been executed, and we have got 100 right over here. Now there is the next thing, right, where our current execution is. So our current execution is on block, inside the block. So you can see as soon as we move inside the execution, move inside the block, another separate scope is created for that block, and that is nothing but a block scope. You can see it from here. So we are the A, since this line is not executed completely, right? So we do not have a value for it. So as soon as I execute this, right, you can see inside a block the value of A is 200, and inside the script, inside basically this script scope, the value of A is 100. So both are two different variables, but just with the same name. So these variable exist in different scopes, altogether different scopes, and these scopes are not basically they are not overlapping each other. They are completely disjoint sets, right? And they exist separately. So now if you print console log of A, so since our execution is inside the block scope, so JavaScript engine first try to find the value of A inside the block scope only. So the block scope, the value of A is 200, right? So 200 will be printed at this point, right? Now as we move further, you will see that block, as soon as any code is executed by the JavaScript engine, it is quickly destroyed by the JavaScript engine. JavaScript engine will not wait for anything. There is a concept of auto garbage collection, right? So as soon as the code is executed, it is automatically garbage collected, right? So the variables, the functions, as soon as they are executed, they are automatically removed from the executions context, right? So you'll see as soon as I execute, as soon as this block is executed, this block scope will not exist anymore, right? This will be destroyed by the JavaScript engine very quickly. So you can see, since I have moved to this line number 21 now, and since we have executed the block scope does not exist. But since we have come back to the script scope, so the script scope exists. And now if you do console log of A, so it will try to check in the same scope, because we are in this, our execution control is inside this scope only. So we will do console log of A. So what is the value of A? That is 100. So 100 will be printed. So here 200 will be printed, and then 100, right? So this is how block and script scope works together, right? I'll just resume and you'll see 200 and 100 getting printed onto the console. So this is how scopes work. This is a very simple, straightforward definition of scopes. You don't have to confuse a lot in this case, right? Although there are different things, different complex things which exist, such as lexical scope and all of those things. I don't want to go into that, right? So for now, we can live with these four kind of scopes for our understanding. Okay. Uh, is this okay till here? You are able to understand? Any doubt in this?
Can you define scope?
So
Is it the scope of the window object?
So script scope exists in case of let and so I'll simply write it. Script scope exists in case of let and const declarations. So I can say if anything is not inside any, if any declaration or any variable declared with let and const, if it is not inside any block, then it is said to be in script scope, right? So this is the outermost scope for let and const, basically, right? This is the out. So in case of where the outermost scope was global scope, but in case of let and const declaration, which is relevant to us, right? This is just for theoretical purpose, right? Because we these days we write let and const only and not the where. So for you, most of the time you will be dealing with the script and the block scopes, right? That is it. So screw whenever the variable or the let and const declaration, they are not inside any other block, right? Such as the block of if or a for or a while or a function, then that declaration is inside the script scope. Is that clear now?
I know.
ठीक है यहाँ तक? All right. Okay. So the scope part is pretty much clear now. So let's talk about the next thing, that is classes or the class syntax, right? So class syntax, index.html and app.js, right? Script app.js and I can say class syntax, right? So why I am calling syntax right over here, we'll discuss that, right? So the syntax keyword is important right over here, right? So when we say classes, right, classes are nothing but the kind of blueprint of an object, right? So technically speaking, they basically contain the information about the object, right? How the object looks like, what are the utility methods associated with the object, right? So they are the blueprint of an object, and they basically uh, defines something called encapsulation, right? Encapsulation, the principle of encapsulation is defined by the classes. So encapsulation means what, right? So there are four pillars of OOPS that I guess all of you knows. The first is abstraction, right? Abstraction meaning hiding the definitions, right? The internal implementation. If you're hiding that, then that is abstraction. You are abstracting it out, right? So there is this thing called abstraction. The second pillar is basically inheritance, right? So where we inherit the properties of the parent objects or the parent class to the child class or the child object, right? So that is the second pillar. Third is polymorphism, and the fourth is encapsulation, right? So encapsulation means encapsulating, right? Encapsulating, capsule, right? Encapsulating in a block, right? So class, with the help of classes, we are able to implement encapsulations in the object-oriented programming languages, right? Because classes have everything. We can bundle everything inside a class, right? We can have the member variables, we can have the member methods, right? Or simply the methods and the variables, right? So classes help us implement the encapsulation in object oriented programming languages. But JavaScript is not completely object oriented, right? No, although no programming language is completely or 100% object oriented, there are some languages are more object oriented and some are less. So no language is 100% object oriented. Okay. So such as, for example, in case of Java is considered to be very, it is very close to object oriented concepts, right? It is mostly object oriented. But if you see C++, although it's an object oriented, but it's not 100% object oriented, right? So similarly, JavaScript is not object oriented language. There are things which of the object oriented concepts which you can implement in JavaScript, right? So for example, we have classes, but technically speaking, classes does not exist in JavaScript. JavaScript engine does not know what are classes, right? So that's why I have written class syntax, right? So this class syntax is nothing but a part of syntactical sugars. Syntactical sugars, right? So syntactical sugar meaning they are just added to the JavaScript to add the beauty, to add the sweetness to the language. They does not, they are not implemented internally, right? JavaScript engine does not know what are classes basically, right? So down the line, everything is implemented with the concept of something called prototypes. I told you to read about this concept, right, of prototypes. So everything is based on prototype. There is something called prototypal inheritance, right? Prototypes. So there are prototypes in JavaScript. On top of prototypes, we have class syntax, right? So class syntax help us write the things in a more cleaner way. That is it. So classes does not exist in JavaScript. They are the part of syntactical sugar and just the syntax. And down the line, everything is implemented with the help of prototypes. So let's see this syntax. What does it look like? So it is very similar to the classes which exist in other programming language, right? So you can write a class keyword. It's a reserved keyword in JavaScript. So you can write class, and you can write, let's say, car, right? Or a very trivial example. So now inside this, now we can have a constructor, right? So this is a method which is called uh, first when we are constructing the object, right? There's a first method which gets called, and herein, let's say we have two things, let's say name of the car and the price of the car, right? And what I can do is this dot name is name. So I'll explain this in a short while, right? What does this keyword means right over here? So this dot price is price, right? And so let me now create an object. So I'll simply create an object C1. And if you want to create an object of this car class, how you can do that? You will have to write new keyword, and then you have to write the name of the class and then parenthesis. So remember the class of on functions basically. I told you that whenever we write parenthesis, that means we are calling a function. So which function we are calling? So we are basically calling a constructor function. So this is our constructor function. As soon as you write a class name and parenthesis, that means you are calling a constructor function. And the constructor function accepts two things, the name and price. So I can simply add BMW, and the price is, let's say, price is 100, right? Like this. So BMW will be passed down to name, and the price will get copied to the 100 will get copied to price. And then what is this keyword? What does this mean? So this basically reference to the object being constructed by the new keyword. So here this new keyword is basically constructing an object, right? That is C1 object. So this keyword basically points to this C1 object only, the object which is being constructed. So for example, if you have some object, let's say I'll create an object, okay? So I'll simply say person, and I'll have name equals to ABC, for example, right? So let's say, sorry, there is a syntax error. So let's say, okay, again a syntax error. So let's say this is the object, right? That is person, right? And if you want to add new properties, how you do it? So you can simply write person dot age, is 21. You can do that. And if you print the person object now, you'll see the age property is added, right? So similarly, what we are doing is we have the C1 object and empty object. Now, since this keyword points to C1, it is very similar to like calling person.age. So instead of person.age, what you're doing is you're saying this dot age. So this dot age will simply add the property. So here the name and price property are added to the object which is being constructed, that is C1, right? So this basically points to an object that is C1. And if you write this line, this means you're constructing an object and you are adding a property inside it, the name property and the price property. And if you simply print it, then in that case, two properties will be added to the car, that is name and price. You can see we have the name and the price. And similarly, you can construct a new car, that is, let's say Ferrari, and I can say 500, right? And let me change the variable name, and I can print the console log C2, right? So you can see this is another car. So you can create as many cars as you want with the help of this car class. So this is a blueprint. This basically tells you that, okay, the car will consist of two properties, name and price. Similarly, uh, since we have properties, in a same way, we can have methods associated with these objects, right? So let's say I have an object called, for example, let's say, for example, uh, print features of the car, right? Let's say this is the uh, or let's say print description of the car, right? Just a second now. All right, so print description. So this method should print description. So since this is a function, you don't have to write the function keyword. It is automatically understood by the JavaScript engine that this is a method, this is a function, right? Associated with the object, print description. So let's say inside this, we want to print the description such as console log, let's say name of the car. Name of the car is, for example, dollar. You can simply write this dot name, and similarly I'll write console.log, let's say price, and I'll say dollar this dot price, right, like this. So we have two cars right over here, the C1 and the C2, and if you do C1 dot print, you can call these objects, you can call these methods on any of the object. So if you call on C1 object, then it will print the description of the C1, So you can see name BMW and price is 100. Similarly, if you call for C2, it will print the description for C2 object, right? So these are the methods which you can create. Similarly, we have the getter and setter methods. So getter and setter methods are used to get a single property or set a single property, right? So getter and setter methods are used to get and set the single property. So by property, I mean this variable, right? So that is fine. Now, how to write getter and setter? So for getter, you write get keyword. This is again a reserved keyword in JavaScript. So you can simply say get name, for example, right? And you can simply do something like this: return this dot name, right? Like this. Similarly, you can write a getter for price, get price. So why do we define getter and setter? Because we don't want to access these properties directly. We want to access them with the help of methods, right? Especially in case of setters, right? So I'll explain that. Price, right? So what I can now do is I can simply say get name, right? So when you're saying get name, you don't have to write a parenthesis in this case, because they are understood. It is understood that these are getter and setters, and they are treated as a property. So you can simply write get name. We'll get BMW, and similarly, we'll if you want to go for C2 dot get price, you will C2 dot get price. So you'll get 500, right? So so these are getter and setters, right? Very price, right? New price, and I can set this price to the object. So I can simply say this dot price is the new price now, right? So this is the setter method, and how setter method works. So you can simply say set price, and you can simply pass the you can simply write set price equals to, let's say, 200, right? So the first car C1, right? Earlier the price was 100. Now the price would become 200. So you can see the price has been updated. But in this case, someone can also update the price to a negative value, right? So for example, minus 200. And if you just print the C1, you will see the price is updated to minus 200, which is wrong, right? The price cannot be negative, right? It should be a positive integer, right? So what we can do is we can put a condition right over here. If new price is let's say negative, right? If it is less than 0, you can simply write it can be 0, right? But it should not be negative. So in this case, what I'll do is I'll simply set the price to, let's say, 0 only, right? If you try to now set the price to negative value, it will automatically be set to 0, right? So this is the benefit of writing getter and setter. So setter, basically you can place a logic so that a wrong value is not updated, right? So you are not updating the variable directly, you are updating it with the help of methods, and this method has all the checks and balances, all the validations, whether you are updating the correct new price or not, right? So if it is a valid new price, then only it will be updated, otherwise it will set to 0, right? So this is the benefit of having the setter methods, right? So if you simply now do set price equals to minus something, right? So it will not work because C2 will be updated to 0 in that case. So 1 second, and I'll have to return as well, okay? So I'll just return from here, right? Just to short circuit the thing. Or if you want to have if and else, you can have that as well. But we can have a simple return keyword that will work. So let's now try it. So let's see the C2. C2 has the price of 500. Let's try to set the price. C2 dot set price, and I'll set the price to some negative value now, right? And if you now check C2, so you can see we are getting a price of 0 now instead of a negative value. So this is how classes are created in JavaScript, and they are very simple. So you can create as many methods you want, right? You can have getter and setter against each property, right? So against name, you can have one getter and one setter, and same one getter and setter for price as well. So I hope this is clear. This is clear to everyone. This part till here. ठीक है यहाँ तक? if we write c1.name and c1.price instead of this dot name, see inside the constructor, the constructor does not know your object name, right? So whatever you are constructing, that is getting constructed at line number 31. So you want to have a generic class right over here. You cannot have c1, you will not always create a c1 class, c1 object, sorry, right? So you need something generic which can help you construct the multiple objects of a car class, right? So that's why we use this keyword instead of simply writing c1 dot name or c2 dot matlab, c2 dot name, right? So that will not work basically, Meghna, right? So that is the thing. Can you show use of print description? That I already showed you, and okay, that's fine. All right. Now this is a simple car class. Similarly, you can do inheritance as well in this case, right? There can be class which can be inherited, right? So for example, I can create a class, right, called racing car, right? So let's say it has few more additional properties in addition to name and price, right? So I can simply say constructor, and let's say top speed is the property which is there, right? So inside the constructor of a racing car, what we can get is we can have few things, right? Name, price, and top speed, right? And now racing car will extend the car class, right? So when we do extend, that simply means we are inheriting the car class basically. And inheritance right over here means inheriting the properties, the methods, the getter and setter and everything, right? Which is there, which is public inside the car class, right? So it will get inherited. And now since name and price, they are the part of the parent class, that is the car class, and they are being constructed inside the constructor of a parent class. So what we can do is we can basically simply call the parent class constructor with the help of super keyword, and I can pass the name and price to the super. So super meaning calling the constructor of a car class. So that will take care of setting the name and price to the object. And then inside the racing car constructor, what we can do is we can set the top speed. So I can simply say top speed is top speed, right? So this will be a key, and whatever the value we'll get inside the constructor function, that will be set as a value. And now I can have for example a method, let's say get top speed, right? So or let's say print top speed like this, and I can simply say console.log. I can simply say top speed of dollar this dot name is basically uh, is dollar this dot top speed, right? Like this. So this is the print top speed function, right, which will print the thing. So all right, let's now create a new racing car object. So I can simply say const r1 is new racing car, and racing car basically accepts three things. The constructor accepts three things: the name of the car, which is BMW, right, and the price and the top speed. Let's say top speed is 400, right? Now if you just go and print the r1, which is the racing car object, you can see we are getting a racing car object. And if I do r1 dot name, you will be able to print name. Similarly, you can do r1 dot get name, right? Because those were the getters which we are inheriting from the parent object, right? The get name and the set price as well. So all of them are getting inherited, and you can directly use them onto the racing car object as well. So you can simply update the price to, let's say, 2000. So you can see this price of 100 will be updated. If you print the R1, you can see the price is updated to 2000. Similarly, let's simply say print top speed. So that's the method, and you can see top speed of BMW is 400. So we are getting the top speed of this car, right? So this is how class syntax work, right? You can just practice this part. This is it. Matlab you will not need to worry about a lot of other stuff which you see in other programming languages. So these are simply the classes, and this is how inheritance works. And just try, the main takeaway right over here is the syntax part, because you might come across this kind of syntax in React or in some other framework, right? Or a library based on JavaScript. You might see this kind of syntax. So the main takeaway is the syntax part, and not the actual object-oriented concepts, right? So please do practice this once at your home, and that should be fine, right? So the class syntax part is over. Now the next thing is something called promises, right? That is the important part. And okay, so before jumping on to promises, uh, we can discuss the, I guess, we can discuss something called callback hell. Okay, that will be that we can discuss, and then we can move on to the promises part, right? So let's take a break, and then we'll continue, right? All right, let's continue. So let's discuss something called async programming instead of callback hell. Okay, so I'll just delete this folder for now. We might be able to discuss it in the next class. So let's talk about something called async programming because that is important. Async programming. Async. And let me have index.html, app.js, script, app.js, h1, let's say async programming. So, all right, let's talk about the asynchronous and synchronous behavior, right? So, first of all, let me tell you one few things about JavaScript, right? That all of you should know. So when we talk about JavaScript, right, JavaScript, so it is basically a single-threaded synchronous language. Synchronous language. So a lot of people out there, right? Even senior developers, they consider it as or they treat it as a asynchronous language. But actually, JavaScript is not uh, JavaScript is not a asynchronous language. It is a synchronous language, right? So what do we mean by synchronous? By the way, single-threaded and synchronous. There are two words, right? Two keywords: single-threaded and synchronous. What do we mean by them? What do we mean by single-threaded?
By single threaded, we mean that it does not handle two tasks at a time in parallel.
Okay. What else? Anyone else? And what do we mean by synchronous?
In
It executes line by line, from top to the bottom.
Okay. Anyone else want to add something more to it? What do you mean by single threaded and synchronous? So single threaded means it can execute. देखो यहाँ पे लिख देते हैं. So it can execute one instruction at a time. Right? So let's say you have written a code in which there are 10 instructions, 10 lines, 10 commands that you want to execute, right? So JavaScript cannot execute them parallelly. It cannot execute a part of your program parallelly, right? There is no parallelism in case of JavaScript, right? Because it is single threaded. It has just got one call stack. Call stack is something where all the execution takes place, right? So for example, let's say this is the browser. This is the browser, and then we have a call stack, or you can say this is the JavaScript engine, right? This is the JS engine, and inside the JS engine, we have a call stack, right? So there is a call stack which takes care of all the execution. So whatever you want to execute, you need to put that thing inside a call stack, right? So this is your JS engine, right? Let me. So this is your JS engine, and this is the call stack. Call stack. This is the call stack. So if you want to execute anything in JavaScript, you need to put that thing inside a call stack, and call stack will quickly execute that particular code or the instructions, right? So this is the browser. We have a JavaScript engine, and inside the browser we have a call stack. That is fine. Now we just have one call stack. That means if this call stack is busy in executing something, this is also known as thread of execution, right? Call stack is also known as thread of execution. That means all the execution takes place here only, and this is our thread. That means let's say if you have 10 instructions, so what you can do is you can put first instruction, then if it is executed, then you can put the second instruction, third instruction, fourth instruction. You can execute like this only, right? We cannot execute, we do not have multiple call stack in this case, right? We don't have multiple threads of execution right over here. So there is one thread, one step, right, which is executing everything, right? So it is a single threaded language, right? It is a single threaded language. That means it has got one call stack, one thread of execution. That is fine, right? It cannot perform parallelism, right? It cannot execute parallel statements or the parallel instructions, right? Now there is this thing called synchronous. What do we mean by synchronous? So it will execute the next instruction uh, only when current instruction is completely executed completely executed, right? So for example, there is one instruction, one for loop, right? And the JavaScript engine, the call stack is executing the for loop, right? So it cannot execute another statement unless this for loop is completely executed. It is completely over, right? And for example, let's say we have a function which is getting executed, which is getting called, right? So if that function execution is still in progress, JavaScript engine cannot pick up any other thing, right? It has to complete the execution for that current instruction, and then it will move to the next instruction, right? So that is what synchronous means right over here. So single threaded synchronous language, right? Now since we have understood this part, now let's talk about few more things. Now for example, let's say I want to create a delay, right? There's a concept of delay. Whenever we deal with application, the process is not instantaneous in the application. For example, the process of fetching the data. For example, I want to fetch the data from let's say Netflix server, right? So there is a Netflix server which exists, right? Netflix server, right? So and this Netflix server, let's say, consists of all of your shows, right? The favorite shows. Now you want to fetch that data to your device, right? Whatever that device is, right? So mobile device or a laptop or a tab, right? You want to basically access this data, you want to fetch this data. Now this process of fetching the data is basically a kind of request response cycle, and this thing is not instantaneous, right? The way you do 1 plus 2, right, in JavaScript, that's an instantaneous instruction, that's an instantaneous execution. Basically it does not need time, it does not need the JavaScript engine does not need to wait for the output in that case, right? It will be instantaneous, it will be calculated very quickly, right? But in case of request, for example, because in application we interact with a lot of things, right? We make requests, we get response. Let's say we have one more server wherein we are doing something, we are basically, let's say there is a payment service which is available, right, which is responsible for all the payment related stuff. So you need to call that payment service separately, and then payment service will respond in some time, right? Because all of these things takes time, right? The request has to travel physically over the optical cables and reach the server. The server will recognize that request, will process the request, and will generate the appropriate response. The whole thing will take time, right? It's not instantaneous. We have the natural limitations to it, right? It cannot be instantaneous. So generally when we deal with the application, we need to wait uh, for the result, for the outcome, right? We whatever we are doing, right, we need to wait for them, right? So for example, now since we just have one call stack, for example, right, and let's say there is 100 line of code, and in that 100 line of code there is one statement wherein we are making a network call, wherein we are making an IO call. So this is basically a case of IO call. IO call means the network calls, right? Input output calls, you can say, wherein we need to wait for something, right? So if you are making that IO call, let's say you are making that with the help of fetch, right? So we are fetching something. Let's say this is some method, right, which fetches the shows from the Netflix server. So now, for example, this fetch takes three seconds, right? So if it fetch takes 3 seconds and we know that it is a synchronous language, that means until unless this fetch execution is over, JavaScript engine will not do anything else, right? Will not go for the next instruction, right? So the JavaScript engine will keep on waiting for 3 seconds, right? So that means what you're doing is you're blocking the thread, right? You're blocking the execution for 3 seconds. Nothing will get executed. The CPU will be idle, and all the CPU cycles will be they will be wasted basically, right? Nothing is happening because we are simply waiting, right? We are not doing anything right over here. So we are basically blocking the thread, right over here. That is the consequence which is happening right over here. But before jumping onto the consequence, let's first try to understand how we can create a delay. For example, you want to create a delay in a JavaScript or any other programming language. There are different ways of doing that, right? So we are mostly concerned with the JavaScript part. So let's say if you want to create a delay, how you will do that. For example, let's say we have a function. I'll call it fun, and I'll say console log inside fun, right? Inside fun. So for example, now if I execute this function, right, it will be instantaneously executed, right? It will be executed instantaneously, right? You can see we are getting the result. But what if I want to execute this fun function after some time? Let's say after 2 seconds or 3 seconds. How will I do that? Right? Is there a way we can do this? We can make this function wait for some time.
You can use set timeout.
Set
Set
time.
timeout.
That is something we have not discussed yet. I'm just asking from the existing things, right? Whatever we have discussed, is there a way you can make this function wait for some time? Can you do that? The call stack same as stack like the stack and heap thing. Yes, it is very similar. It has all the property of stacks, right? The pop and FIFO order is basically followed, right? LIFO, last in first out, not FIFO. FIFO is for queue. All right.
Recursive call.
How you will make it like if I want to say, if I am asking you that, okay, uh, I want to execute this function after 3 seconds, how will you do that? Recursive way, how will it will help? I'm asking for 3 seconds. I might ask for 5 seconds as well, for 10 seconds as well. How will you make that happen? Is there a way we can create a delay? बोलो भाई.
Using await keyword.
No, so we are mostly concerned with whatever we have seen so far, right? Nothing new, nothing fancy we have to do.
We cannot do it without asynchronous JavaScript. We cannot do it.
Sorry, we can't do it. We can do it, yeah. So we can make a use of time basically, right? A time utility which is available, not the time utility, but the dates basically, right? So there is a date object which exists in JavaScript, very similar to math object, wherein you can deal with the dates. You can add the dates. You can add the hours, months, years with the dates, right? So all of those things you can do with the help of date object which exists, but herein we are interested with few things. For example, we have something called date object, and I'll create an object of date, and I'll simply say date dot something called get time, right? Date dot get time. So what is this thing, date dot get time? We're getting a number, right? We're getting a number and it is changing each time I'm executing this function. Anyone? So see, this is nothing, this time, this number which you are getting, right? This integer which you are getting is the time, right? This is the time. We call it epoch time basically, epoch time. So this is the time which has elapsed from 1st January 1970, right? In milliseconds. Right? So this is the time which has elapsed from 1970 till now, till the moment we executed this function, right? This is the time which has elapsed in milliseconds, right? From 1st January 1970. So this was basically the date which was chosen as a result of the standardization process. So we started moving towards standardizing things, right, around 1970. There were a lot of standardization which took place for different quantities. The same we did for time as well, right? We started measuring time from 1970, right? This is just a standard that you see. So this is the time which has elapsed from 1970 till now, right? Till the moment you executed, right? So for example, let's say if I execute uh, let's say if I execute the code at, if I execute this line, right, this function get time at some point, right, let's say 0.1, and so we'll get some value, let's say value 1, right? We will get some value, and after some time, let's say this value will be something else. For example, if I simply add 3000 to it, that means 3000 milliseconds to it, the value 1, right? So as the time will pass, as the 3 second will pass, so let's say this result is let's say t, right? As the result will, as the time will pass, and let's say if we keep on if we keep on checking the value of get time, right, again and again and again, instantly, again and again, right, very quickly, so the time will come where the get time will be equivalent to this t, right? Is that correct? Are you able to understand this part or not? So
Yes.
let me just show you with the help of example, right? Let me just show you with the help of example. So for example, let's say I'll create a function. I'll create a function called delay, right? This will create a delay for us. So what it will do is it will simply say current date, right? That will be new date, right? Uh, new date, and new date dot get time we can do, right? Current epoch time we can find out, right? New date dot get time. So that is fine. Now what I'll do is I'll add let's say hmm, const end time, right? I'll say end time will be current time plus, let's say I want to create a delay of 3 seconds. I'll simply, what I'm doing is into the current get time, I'm simply adding the 3000 milliseconds. And now what I'll do is I'll put a while loop, and I'll simply say new date dot get time should be less than the end time, right? And I'll keep on executing this loop, right? So a time will come, right? A new date dot get time will basically exceeds this value, this end time value, because we had at the time of this delay function's execution, we had captured this value, right? For example, this value was let's say 10, right? And we added 3000 to it, so it became 3010. So we'll start from basically 10, and it will keep on incrementing till we get this end value, right? After 3 seconds, this condition will become false and the while loop will end. So while loop will keep on executing for 3 seconds in this case, right? Is this part clear to everyone or not? First tell me that. Is this thing clear?
Yes, sir.
It is a very obvious thing, right? Because new date dot get time is giving the time in millisecond, that instant of time, right? Which has been elapsed from 1970. So we are getting a epoch time right over here, the current epoch time. And what we have done is we have basically stored the current epoch time and we have added 3000 to it. That means this end time will be 3000 milliseconds ahead of this current epoch time. So as the while loop keep on executed, will keep on checking for this condition that okay, what is the current epoch time, what is the current epoch time. A time will come after 3 seconds that current epoch time will exceed this end time, right? And therein the while loop will stop, will halt, and will come out of the delay function, right? The delay function execution will be complete, right? So, and after this we can simply execute our fun function, right? So what I can now do is I can basically put a console statement. I'll simply say start, and I'll simply say console log end, right? So let's now see if we are able to create a kind of delay or not. So you can see, uh, let me call the delay as well, okay? Let me call the delay function. We didn't call it. So you can see start, and it's keep on, it will wait for 3 seconds and then it will call the fun function. Fun function will print inside fun, and finally the execution will end, right? So you can see everything is getting executed synchronously. This is the first statement which is getting executed. Then we have a delay function call. The function call will be executed and it will wait for 3 seconds, and once 3 seconds are over, then it will call the fun function and the fun function will be executed. And once fun function is executed, delay function execution is complete, and then the end will be printed. So you can see everything is getting executed in a synchronous fashion, synchronous manner. But what is the problem right over here? What is the problem with this code? So for example, if we put a button right over here, right? So let's say I'll call it a click me. I'll say click me, right? Save. So I'll just zoom in, not the console, but the viewport. So if we execute this and if I try to click on this, you can see I'm not able to click on the button. Now I am able to click, right? But during the execution, I'm not able to click, right? I'm not able to click on that button anymore because the call stack, right? Call stack is busy in executing that while loop, that delay function, right? And it can't do anything. It can't, it does not have time to execute any other thing, right? So generally when we click on the button, so there are multiple things which happens in your call stack, right? Automatically. So those things are not, since call stack does not have time to execute anything else, the whole thing is freezed. Everything is freezed, right? The whole application is freezed for that particular amount of time, right? So if this delay is huge, let's say this delay is 100 seconds, for example, then your application will freeze, your server will freeze. It will take a lot of resource of your system, lot of CPU cycles will be used in this case, right? So this is not the correct way of creating a delay. Though we are able to create a delay, but the impact of this delay is very adverse on the application part, right? On the browser itself, for example, right? The browser is freezed, the user can't navigate to anything, user can't click on the button, user can't check the menu or whatever the application is about, right? You can't do any operations after the this delay has started, right? So this is a very bad thing that you can do to your application, right? We should never create a delay like this, because there is no parallelism, there is no parallel call stack which is available, which can do the rest of the stuff which is available, right? So there is one call stack, and the nature of the language is synchronous, right? it will not do anything else until unless delay is executed, right? So there is a problem, right? There is no way by which we can create a delay without blocking the thread, right? Without blocking a thread, we cannot create a delay in JavaScript. If you create a delay by writing a code like this, then you will end up blocking the main thread, the call stack basically. I hope this is clear to everyone, this part. Is this okay till here?
Yes, sir.
So we'll not be able to complete this topic today. So I'll continue in the next class probably. So there has to be something else which should solve this problem, right? Because in JavaScript there is nothing which exists which can create a delay without blocking the main thread. Right? You can't do that in JavaScript, right? So we need something from outside. We need something from the browser, right? Because JavaScript engine does not have anything to do that, right? So we need something from outside, and that outside thing is the browser, and the browser has few of the utilities which are available, few of the superpowers, you can say, right? Uh, so browser has got few things related to, if you want to, let's say, work with the time, right? It has got few things, few utilities which can help us with the time, right? It has got the power to deal with the timers, right? So here, for example, in our case, we need a timer, that's it, right? We just need to measure for 3 seconds and then we wanted to call the fun function, right, without blocking the main thread. So that browser can allow us to do that, right? Browser can help us in that task basically, right? So there are timers basically. If you want to access the geolocation, for example, right, JavaScript alone can't do that. So we need something from outside. So browser can help us in that, right? Browser can provide us the geolocation information, for example, the latitudes and the longitudes that we need, right? Then let's say if you want to store something, then JavaScript cannot store anything permanently, right? JavaScript engine does not have that utility, right? So but browser has those things, right? Browser can basically do the storage part for you, right? It can store the things permanently, right, onto the disk. Then if you have Bluetooth, right, if you want to connect to the Bluetooth, then definitely you can again use the superpower of a browser, and you can access this superpower inside the JavaScript engine, inside the call stack, and you can use the Bluetooth, right? Then similarly, very similar to this, we have something called fetch, right? If you want to, let's say, if JavaScript uh, with the help of JavaScript, if you want to connect to the Netflix servers, or let's say if you want to connect to any external server outside, right, then JavaScript alone does not have that utility, does not have that facility to basically connect to the external servers, right? So therein browsers helps for comes for the rescue, right? So there is something called fetch. So this browser, this has got lot of things, right? It is one of the remarkable invention, right? So this has the superpower to connect to the external servers as well, right? It can make the request to the external servers, fetch the data from those servers, and that thing, that utility, we can access inside the JavaScript engine. How we can access? There is a way to do that, right? So all of these things, these are not the part of JavaScript. They are not the part of JavaScript. They are part of the browser basically, right? So there are a lot of things which exist inside your browser which we can access as per our requirement, and we can use them, right? So how JavaScript engine can access all of these things? So there is this thing called window object, right? I told you that there is one global object which exists in case of browser, and that global object is nothing but a window object. So window object basically act as an interface between the JavaScript engine and your browser's web APIs. So all of these superpowers, they are basically known as web APIs, right? Web APIs meaning web meaning the browser's API, you can say, right? So these are all, it act as an interface, right? So if you want to access anything uh, related to web APIs inside your JavaScript engine, you can use the window object. So if you just go and write window, for example, so this is an object which exists inside your JavaScript engine, and it acts as an interface. So if you just expand So there are things like you can see there are things like fetch, right? So this is the fetch which help us to connect to the external server. It's the same thing, right? Which I told you, right? So this is a fetch, and we can access it with the help of window object, and this is a part of the browser, not the part of JavaScript, right? So a lot of people confuse themselves that it is a part of JavaScript. It is not a part of JavaScript. It is the part of the browser's web API environment, right? So that is fine. Then you can see there are different type of databases which exist, right? IndexedDB, and there is something called local storage which exists, that you might see right over here only. You can see local storage. This is the kind of storage which is available inside the browser, and we can access it in the JavaScript, right? Again, through the window object, that magical window object, right? So again, there are things related to timers as well. So let's check that. So there is this thing called RS. So you can see there is something called set timeout and set interval. So these are the utilities which help us in dealing with the time, right? When we are dealing with the time or the time intervals, right? We want to call, let's say, some function, invoke some function after some time, then we can utilize these superpowers provided by the browser. So set timeout and set interval, they are not the part of JavaScript. They are the part of the browser's web API, right? So so these are the timers, and there are other things as well related to geolocation. If you want to see, then you can check on MDN as well. It's a very simple thing. Geolocation, MDN. So you can see geolocation API allow users to provide their location to web application if they so desire, right? And so yeah, you can access the things like this, get current position and all of those things, right? So again, so these are all these things are part of web APIs. That's why they have called it API, right? Geolocation API, because it's not a part of native JavaScript, right? The part of the browser. So and with the help of window object, we can access all of these things. So this is about today's class, right? I'll discuss more things in the next class, and we'll continue from here. We'll try to build up the concept, and we will try to figure out why do we need promises ultimately, right? Why do we need this async programming, right? And how we can basically write the async code, right, in JavaScript. Although the language inherently is a synchronous language, right? But we can write a asynchronous code in JavaScript. By nature, by virtue, it's not a asynchronous language, right? By default, it's not. But we can write with the help of few things, with the help of browser, right? With the help of browser, we can write the asynchronous code in JavaScript, and that will help us unblocking this main thread, this call stack, right? In that case, the call stack will be free. It will not